All right, let's take a look at some multi-step conversions. When you're doing a multi-step conversion, you always go through moles. Moles is always in the middle. So I'm going to outline each of these, and then I'm going to do the work on a sticky note because there's not a lot of space here. And I already have my molar masses for all of the things worked out. Okay, so we're starting with liters, we're going to grams. So we start with the volume of HCl. Then we'll go to the moles of HCl. And then we'll go to the mass of HCl. That'll be our 3 steps. So we know our volume is 643 liters, and that's 3 sig figs. So now we can figure out our moles. Well, to do that, all right, so I'm just going to put a sticky note on here so I got a little more space. To do that, right, we use our 22.4. So how many moles are in 643 liters if 1 mole is 22.4 liters? Right, so we're going to do 643 divided by 22.4. 643 divided by 22.4, 28.705. So we get 28.705, and this has 3 significant figures. Now, we keep this number in our calculator, and we just make note that it has 3 significant figures in it. All right? But we want to keep more than 3 significant figures in it while we're doing our calculations. So now we're going from moles to mass, and to do that, we're going to use the molar mass. And I already calculated the molar mass, so I don't have to show that. And you know how to do that. 36.461 moles per grams per mole. Okay, so how many grams are there in 28.705 moles if there's 36.461 grams in 1 mole? Now you can see we're just going to multiply those 2 numbers together to get our answer. So I take that answer that I had before, it's still my calculator, and times it by 36.461. 1046.63. So my mass of HCl is 1046.626 grams. Now, I want my answer to have 3 significant figures like my starting thing, because 3 is the smallest that I had when I did all of these multiplication and divisions. So it's going to be 1050. So my answer is 1050 grams HCl. 3 sig figs right there. All right, so it's not so bad. Just map it out and then do 2 conversions. Really, it's not too hard. So first one, next one. We know our mass of our H2O. We're going to go from our mass to our moles of H2O. And then from our moles of H2O, then we can go to our particles of H2O. Right, from mass to moles, we're going to use our molar mass. From moles to particles, we're going to use our Avogadro's constant. All right, I'm just going to put a sticky note on here so I can do the work. So what I know is I've got 59.72 grams, 4 sig figs. And my molar mass for water is 18.015, 5 sig figs. So start off. How many moles are there in 59.72 grams of H2O if 1 mole has 18.015 grams? This times this divided by that. So 59.72 divided by 18.015, 3.315. So I'm just going to write it down. My moles, 3.31502. And we want this to have 4 sig figs so far. Okay, because our first guy had 4 sig figs, this guy had 5, so our answer to this question is 4 sig figs. Now we use Avogadro's constant to do the next one. So I don't know my particles, so how many particles are there in 3.31502? And that number is still in my calculator, moles. If there are 6.02 times 10 to the 23 particles in 1 mole. Now this guy only has 3 sig figs. So our answer to this question can only have 3 significant figures. So we're just doing the 3.31502 times the 6.02. So times 6.02 times 10 to the power of 23. 1.9956. Yeah, 1.995639 times 10 to the 24. Now, I want 3 sig figs. That's to there. But when I round this to 3 sig figs, I'm going to get 2.00 times 10 to the power of 24. That's my answer. So my answer is 1.995639 times 10 to the power of 24 particles. And we round that to our proper number of sig figs of 2.00 times 10 to the power of 24 particles of H2O. So again, not too difficult. Just takes some work. Next one, we got 4 grams of sodium, 2 atoms of sodium. Well, you know, this question is the exact same question as this one above. So we're not going to bother with it. We're going to cancel that one out just to save some time. 1.35 grams of N2 to how many liters of N2? So in this one, we're going from mass of N2. We got to convert it to moles of N2 using our molar mass. Then we go from moles of N2 to volume of N2 using our 22.4 conversion. I'm just writing those down there to remind myself what conversion I'm using. So we start off with 1.35 grams. That's got 3 significant figures. I'm just writing these things down to remind me of what's going on. So we put this up, write it out. How many moles are in 1.35 grams of N2? If we've got 1 mole of N2 is 28.014. So 1.35 times 1 divided by 28.014. So 1.35 divided by 28.014. 0.04819. 0.04819. So my moles is 0.04819. And I want 3 sig figs in the end, but I keep more here than 3. I've got 4 here. And I keep my whole number in my calculator so I can continue to working with it. Now we do the second conversion, right? I don't know my volume. So you go, how many liters are there in 0.04819 moles? If there are 22.4, 3 significant figures, liters in 1 mole. So I multiply those out. Times it by 22.4. 1.079. So 1.07946 liters. But I want this to have 3 sig figs. So my final answer with 3 significant figures will be 1.08 liters of N2. All right, so map it out. All your conversions. Remember, moles always go in the middle. Let's take a look at this last one. Oh. We've got a lot here. There's 3 more here to do. We're not going to do them all. Ugh. Okay. Oh, we'll do a couple more. That's it. These take a long time. Consider CaSO4 gypsum. What is the molar mass of CaSO4? So you should be able to do these pretty quickly on your calculator. CaSO4, we take our enter. So if we look here, here's my calculator. I'm going to do Ca is 440.7078. And I'm going to add to that my S, 32.066. And I'm going to add to that in brackets my O, 15.999 times 4. Hit my enter, 136.14 grams per mole. How many moles are there in 12,100 grams? All right, so let's do that one. Let me just get some nice, better. How many moles are there in 12,100 grams? So how many moles are in 12,100 grams if 1 mole has 136.14 grams? All right, so we take 12,100 and divide it by the 136.14 to get 88.879. And we should have 3 significant figures in this, so 88.9 moles. So how many molecules are there? How many molecules are there? So how many molecules are there? We take this number, we multiply it by our Avogadro's constant to get a big number. You can do that. How many moles of oxygen atoms are there? Well, there's this many moles of the whole thing. Right? There's this many moles of CaSO4. But now how many moles of just O are there? Well, if we were to separate out these O's, we would have 4 times as many O's in a counting sense. So we'd actually have 88.879 times 4 moles of oxygen atoms. Right? Because this oxygen, there's 4 oxygens in every molecule. So if we're just thinking about counting just the oxygens, right, there's this many moles of this whole molecule. But now if we just wanted to count the oxygens, there would be 4 times as many oxygens as this many moles. You know, that's all we're going to do for this one. We're not going to do the bottom 2. I think that you could figure it out. Well, this one will be a little bit difficult, but I'm not going to ask you a question like that on the quiz or the test. And these do take a while, so I'll let you get to the homework for this. Thank you for watching.